addition reactions of benzene that follow free radical mechanism. This is today's lesson. In this lesson, we are going to learn reactions of benzene, that is hydrogenation of benzene, chlorination of benzene, ozonolysis of benzene, and finally mechanism of these reactions. So let's go to the detail. First point is reactions of benzene. Let's see. This is benzene, hydrogen in presence of nickel catalyst and at 200 degrees Celsius temperature. Then 3 molecules of hydrogen combine with 3 double bonds of benzene. Then we get this compound. Its name is cyclohexane. When benzene is treated with chlorine in presence of sunlight, then we get this compound, which is benzene hexachloride, or 1,2,3,4,5,6 hexachlorocyclohexane. Benzene hexachloride, or 1,2,3,4,5,6 hexachlorocyclohexane. Again, when benzene is treated with ozone, then 3 molecules of ozone in presence of carbon tetrachloride, then it is hydrolyzed with warm water in presence of zinc. Then we get, from this benzene we get 3 molecules of glyoxal and zinc oxide. All the reactions involve 3 molecules of reactants, that is 3 molecules of hydrogen, 3 molecules of chlorine and 3 molecules of ozone. These reactions prove that benzene molecule has 3 carbon-carbon double bond. From the hydrogenation we get cyclohexane. From chlorination we get benzene hexachloride, or 1,2,3,4,5,6 hexachlorocyclohexane. And on ozonolysis, from benzene we get glyoxal and zinc oxide as byproduct. This is benzene hexachloride, BHC, benzene hexachloride. This is addition reactions of benzene, that is hydrogenation, chlorination and ozonolysis of benzene. Now let's see mechanism of these reactions. Now mechanism of hydrogenation of benzene. Let's see. First of all, hydrogen molecule undergoes homolytic fission in presence of nickel catalyst and at 200 degrees Celsius temperature. This hydrogen molecule undergoes homolytic fission. One electron of this bond comes to this hydrogen and another electron of this bond comes to this hydrogen. This is called single-headed arrow or one electron arrow. It means one electron of this bond goes to this hydrogen and another electron of this bond goes to this hydrogen, and as a result hydrogen free radical is formed. Now step 2, this hydrogen free radical combines with this benzene. With any carbon atom of this benzene. Suppose this hydrogen free radical attacks this carbon, then one electron of this double bond comes to this carbon and another electron of this double bond comes to this carbon. Then we get hydrogen here double bond, here double bond, and this carbon becomes carbon free radical because of this electron, one electron of this carbon-carbon double bond. Now this carbon free radical of benzene combines with another hydrogen free radical, that is this hydrogen free radical combines with this carbon. Then we get hydrogen, here one hydrogen and another hydrogen, that is this hydrogen, here double bond, here double bond. Similarly, for these two double bonds, another two hydrogen molecules combine with these two double bond, and finally this compound is formed. That is cyclohexane. So this is the halogenation reaction of benzene that follows free radical mechanism. Now mechanism of chlorination of benzene. Let's see. Step 1, chlorine undergoes homolytic fission when this is exposed to sunlight. On homolytic fission from chlorine free radicals are formed. One electron of this bond comes to this electron and another electron of this bond comes to this chlorine in presence of sunlight or H nu. In the second step, this chlorine free radical combines with this benzene, hydrogen, here double bond, double bond, double bond. This chlorine free radical combines with any carbon atom of this benzene ring. Then we get hydrogen, chlorine, double bond, here hydrogen. This carbon becomes carbon free radical. This carbon free radical of benzene combines with another chlorine free radical, and then we get here double bond, here double bond. For these two double bonds of benzene, another two chlorine molecules combine to these two double bonds of benzene. Then we get this compound, which is benzene hexachloride or 1,2,3,4,5 hexachlorocyclohexane, which is known as gamaxane, which is crystalline solid used as insecticide. And this is the mechanism of chlorination of benzene that follows free radical mechanism. Now, mechanism of ozonolysis of benzene. Let's see. First of all, benzene is treated with ozone, 3 molecules of ozone in presence of inert solvent carbon tetrachloride. Then we get carbon, this carbon and this carbon, there is a double bond here, oxygen and then carbon. With this carbon, here carbon-carbon double bond, this and this carbon and this carbon, there is a double bond. This carbon and this carbon, this is the another bond. Here ozone, oxygen, 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 ozone molecule. Here another ozone molecule. Here another ozone molecule. All the carbon atoms carry one hydrogen atom each. Now these bonds break in this way. Here we get CHO, CHO. Similarly, after breaking these bonds, we get another molecule of CHO, CHO. So here 2 CHO, another molecule CHO, CHO. So total 3 CHO, CHO molecules, that is glyoxal. This is the lowest molecule of dialdehyde, and this molecule is hydrolyzed with warm water in presence of zinc. This zinc combines with oxygen to form zinc oxide. This is mechanism of ozonolysis of benzene, in which glyoxal is formed. This is all about addition reactions of benzene that follow free radical mechanism. Number today, thank you very much.